Yo, Coach Ray back here with the next PieceWise video, and specifically what I'm going to show you how to do is plug in a PieceWise function onto Desmos. And it is complicated. I don't think Desmos did a good job of figuring out how to plug it in, but I'm going to show you. I will tell you, if you don't know how to plug it in correctly during a test, then it won't help you. So if you have it memorized and you can use it, then you will be allowed to use it on a test. All right, so I'm going to take example 1 from our evaluating PieceWise notes, and I'm going to plug this into Desmos. Okay, on Desmos. It's in function notation. PieceWise functions are always in function notation. So I'm going to start with f of x equals. Okay, with PieceWise functions, they always start with that giant sideways mustache. It's called a brace. Desmos does have those, so we're going to use that. And down here in this ABC button is where I'm going to click to find it. Click. And then it's down here in the middle, you'll see these little sideways mustache braces. Okay. Next, I'm going to start with the top line of our PieceWise function. Okay. The top line of our PieceWise function is this 3x plus 1 is the function. Okay. And the x is less than 1 is our boundary. In Desmos, they kind of flip it, and they have you start by typing in the boundary and then the function. Okay, so my boundary for the top line is x is less than 1. So in my Desmos here, I'm going to start with x is less than 1, just like that. All right, after the boundary, to separate your boundary from the actual function, you use a colon. All right, a colon is the 2 dots. A semicolon is a dot and a comma. So we do our boundary, and then we separate our boundary from our function with a colon. So now I'm going to plug in my function. I want to double check. I believe it was 3x plus 1. Yes, it was. So now I'm just going to plug in my 3x plus 1. All right, so I got my brace. I've got my boundary first. I've got my colon, and then I've got my function. My entire top line is now plugged into Desmos. So far, so good. The colon you're going to have to memorize. The fact that the boundary comes first, you're going to have to memorize. Okay, but in order to separate from my top line to my second line, I can't go down. I got to keep going in a line all the way across. I use a comma though. So to separate my top line from my second line, I use a comma. Yeah.
When you say boundary, do you mean all the inequalities?
Yes, the boundary is the inequalities part that's in the back. Okay, so let's see. So I've got my whole top line. I'm now going to start my second line. So what's going to come next? Boundary goes before the function. So I'm going to put my boundary on the second line in. So my boundary in the second line is this one that says 1 is less than or equal to x, which is less than 4. So I'm going to type it in exactly how it looks. 1 is less than or equals down here, x, okay, less than 4. How do I separate my boundary from my function? Colon, comma, separate one line from another. All right, so I've got that boundary typed in. I got my colon. And the function on the second line was just the constant 2. So all I need to type in is 2. Okay? How do I separate my second line from my third line? Comma. Okay, so my last boundary was x is greater than or equal to 4. How do I separate my boundary from my function? Colon. Okay, and I'm going to go back and double check. The function on that bottom one was 6x minus 3. So I'm typing in 6x minus 3. God bless.
Thank you.
Okay, we can't see the last part, and that's just because we have to zoom out. And we've dealt with that before. So I'm going to kind of bring it to the middle and zoom back in so I can still kind of see this. All right, and all I want to explain here, and eyes up front, is, so in our PieceWise function, because we're going to start messing with the graphs now, we're basically saying x is less than 1. X is right and left. So another way of saying this is like when we're left of 1, this is the function that we use, the 3x plus 1. Okay, so if you compare that to the graph, here's 1. When x is less than 1, meaning to the left of 1 over here, this is the graph we use. There's our 3x plus 1. There's our 1 as our y-intercept. We've got a slope of rise 3, run 1. Okay, the middle section had a constant, right? We said between 1 and 4, it was just a constant of 2. So you see my constant of 2 right there, and that's in between 1 and 4. All right, and the last part is if we're bigger than 4, then we're using this one. This was our 6x minus 3, I think. Okay, Yeah, our 6x minus 3 function. So that's this line. So what I want you to see is piecewise graphs look crazy, but you just see the 3 different pieces. The first piece is the one on the left, the middle piece is the one in the middle, the right piece is the one on the right, and they all are different lines, so they're all going to look different on the graph. Okay, that is. Here's one more thing I want to show you on Desmos. I don't know if it's more efficient to plug into Desmos with piecewise because of you have to memorize the boundary comes first, the colons, the commas, all of that stuff. But here's one reason where it would be great. If I gave you like 10 evaluating problems, for example, I think we did f of -3, it gives it to you right away. Okay, and if we could do 10 of them real quick, f of 10, f of 5, if you wanted a huge one, f of 1024, it will immediately spit out all of these answers. So that might be something where if you take the time to plug the piecewise function in, and then you got to evaluate a bunch of them, that might save some time there. Okay, so just a heads up, this is a possibility, and that is how we plug them into Desmos. Might help with the graphing, might help with the evaluating, and so on. All right, stay tuned for the next piecewise video. We're just going to keep knocking them out.